Welcome to video number 4 on fun with the Arduino. In the previous video we investigated how we can connect an external LED using a series resistor in order not to blow anything up. In this video we're going to write the code for that. This is the hardware that we need to try it out. We have a push button connected to pin 2. No special reason why it is pin 2, but just have to select a pin. And then we have a LED and a resistor connected to pin 8. If you do not yet have a push button, you can simply use a wire that you connect manually to simulate the push button. And if you don't have a full range of resistors at home yet, any other value close to 330 will do, as long as the LED lights up so that we can see it work. Well, we can use the code that we prepared in video 2. We had the onboard LED which is hardwired to pin 13, and we used the push button to switch that on and off. So actually, if we would change 13 to 8, the new pin number for our external LED, then we would be ready. But that's not what we are going to do. Why not? Because this code, already with this very short code, we need to make a change at 3 locations. Now suppose that we have an Arduino that's doing a lot of stuff, 100 lines of code, and then we would like to make a change of a pin number. Then we would have to scan through all that code to find all the lines where we need to make that change, and that is, well, quite tedious and error prone. We could easily forget one. So the goal for this little video here is that we are going to write more readable and more maintainable code. And then a second goal is we are going to play as if that one LED is the street lights on our model railway layout. So it's probably not one LED, but maybe 20 or 40 even. In the next video we're going to see how to connect those, but right now we're going to simulate a night cycle. If we press the button, then the street lights switch on, and automatically after say 3 minutes they switch off again. Okay, so the define statement is a very nice statement that we can use for our first goal, readable and maintainable code. What does it do? It simply exchanges one text with another text. So if I would write define push button pin 2, then everywhere in my code where I use the word push button pin, the Arduino will read 2. And that is very convenient to make maintainable code and readable code. So let's do that. This is the code that we prepared in video number 2, and instead of going to change the 13s into 8s, we're going to add a couple of defines to make this code more readable. Let me do that. We had a push button, use an underscore with that. That is one of the conventions in code world. It was on pin 2, and I did not need to make another space. Another define is for the street lights on my model railway layout, and that was, well, we are now at pin 13, so let me just change this code with these new defines first and then see how maintainable it is. Everywhere in my code where it said previously pin 2, I'm going to change that now with the readable word push button, and everywhere where it said 13, I'm going to change that into this readable word streetlight pin. And see what happens. My code is readable by itself. So why would I use these commands? I'm only repeating the obvious. I can do with much less commands in this code because yeah, my code itself already tells what these things are. The code is obviously a few lines longer, but the big plus is it's readable, and it is maintainable, because see what happens now if I want to make this change. Pin 13 has to become pin 8. All I need to do now is change my define, and in one go I'm ready. That is very nice, of course. Why have I written the streetlight pin and the push button pin in all capitals? Well, that is just one of those code conventions or style guide conventions between C++ programmers. There's a whole range of those conventions, and if maybe you are more interested in reading them, follow the links that are in the text that goes with this video. Okay, now let's go to our second goal, how to have the lights stay on for 3 minutes. Well, obviously we need to change something here in our if statement. Let me first take this one line down, and then proper coding use some indents, and I can take away the else, because I want a couple of things to happen when I push, or if I push the button. Then I want the lights to go high, yes, and then I want this 3 minutes to happen. A quick and dirty way to do that is use a delay statement. The delay statement works with milliseconds. 3 minutes is 3 times 60 is 180 seconds. 180 seconds is 180,000 milliseconds. So this looks good, but with an if statement followed by multiple lines of code, we will need an extra set of these curled brackets. So let me add those two, and then we should have the code that works. So let's read it. If the push button goes low, it was attached to ground, then I first switch on the lights, then I simply do nothing for 3 minutes, and then I switch off the lights. Well, this should work. One more thing that I like to do, I do not like this 180,000 over here. I want to have another define here that says street lights on time. Yeah, it's a long word, but why not? It's good readable. And that is the text that I am simply going to add here to my define, so that I can change it easily. Copy paste, yeah, and that was 180,000. So now I have a configurable time. If I want to change this time, I can easily do it. Well, I want to make the first change right now already, because I am going to test this code, and I don't want to wait for 3 minutes during my testing. I only want to wait for, say, 3 seconds. How much is 3 seconds? 3,000 milliseconds. Oh, this is one where I could use a text, a command to explain what is happening here. The units are milliseconds, so 3 minutes, I'm going to say, is 180,000. So then anyone knows that this was happening in this line. This is readable code, it's maintainable code, and let's now test. Okay, it's time to try it out. I'm going to press here this upload icon in the top left, and then in the bottom right we see the progress bar. And on the Arduino we should see the lights blinking that the code is being uploaded. Well, it's finished. Over here I have again my bomb destination device push button, and over here we have a red LED connected. So if I press the button, my night cycle starts. Yeah, the LED lit up, and it does that for exactly 3 seconds. So that works quite fine. Now let's make a quick change. I'm going to change 3000 into 6000. That is a 1 second operation. I'm going to upload the code again. and then we will see the lights on the Arduino blink again. Yeah, the code is there. Now I'm going to press the button again, and the LED, this one over here, should light up for 6 seconds. That was quite a fast change. This is maintainable code. Well, this was it. Now, of course, the question is, how can I get not only one LED connected to pin 8, but I have 20 street lights with powerful white LEDs in them. How can I make those work on this Arduino? And that is the subject of the next video. Maybe see you back there. Bye bye.